I'm only. All right. This is scaling VLANs, right? We're going to talk about, like olden days, Cisco, we talked about making VLANs. Now we're going to talk about growing them using VLAN tunneling, how we can use extended ones, DTP. We're going to troubleshoot them, talk about switching on layer 3. What craziness is this? Then using layer 3 switches to forward data along here. Here is a bunch of words on a PowerPoint slide. That's insane. So DTP, the trunking protocol, this is one of those things that I wish I knew about back in the days when I was working at Tribune. I should have read my manuals a little more closely. Lets you manage everything on a switch if the switch is configured to be a VLAN trunking protocol server, DTP server. When you reset a server, or a switch rather, they always mention to delete that file. So routers don't have them, but on a switch you have to make sure you delete them out. When you're set up to do this, you got 3 modes to work with: server client and transparent. And there are 3 advertisements they'll ask you to be familiar with: summary, request, and then a subset of advertisements. So another fun chart for us to make. There's a bunch of different versions out there. Isn't that great? If you do the privileged exec command, it show you what's going on the protocol. The revision number will let you know whether the existing database is current or it needs to be replaced. And then if you're plugging switches into your network, if it doesn't know about all this VLAN nonsense, it will break. So you have to make sure that it has the default for your network configuration. How do we set this stuff up? Well, set up a server, give it a name and a password, a domain name, domain of the VLAN. Add some clients, and then configure the VLANs on that server so that they echo out to it. We'll help Cisco out here. And then verify that they have that information. And if you see down here, we've configured 3 VLANs: sales, marketing, and accounting are the ones we care about. You can almost. And then currently, if you do, this is the output of show VLAN brief. Currently none of the ports are on that. Right, so kind of sitting there waiting for stuff to happen. There's a normal range, and this is like one of those holdovers from this is how many bits we assigned to this VLAN field, between 1 and 1005. Those are normal VLAN ranges. There's an extended VLAN range where we added a couple more bits to the process to extend that out to 1006 to 4094. So VLAN ID is less than 1005. It's a normal range. If it's above that, it's extended range. That matters because the tunneling protocol can't deal with these guys. So if you're creating VLANs and you need more than 1,005 of them, fix it. Right? Because 1,005 of them, you're in trouble. But you should. It's for crazy people. You can also enter a series of them into your device separated by commas or hyphens, a range of VLAN IDs. So those are the iOS commands you use to plug that in. Get into VLAN, give it a number after you're configuring, and then configure that. Remember, we talked briefly about the switch virtual interface. These are the same commands that we did there. So now you've created a VLAN. Maybe you've given it an IP address you can manage by it. then you have to go and put those ports into those VLANs. So you remember back a couple of slides here, all of these ports are someplace that does us. So our next step is to go in and put them in there. These are our commands to memorize. Config T, get in there, interface, pick your interface you're working with, fast Ethernet 0/0/1, switch port mode access. Important to set your switch ports to access unless they connect to another switch. This is kind of a holdover where your switch will try and negotiate with whatever's on the other side of it. And now that computers boot up almost instantly, as far as like switching hardware is concerned, they would get you into trouble. The computer would come up and start asking for DHCP addresses before the switch was configured, before the port was configured. So in an office environment, your sales guy would come in, plug in his laptop, turn it on, and his laptop would come up and say, give me an IP address. Well, if the switch port mode access isn't enabled, if somebody's done a no switch port mode access, the switch port will be sitting there trying to figure out what's going on in terms of its architecture before that DHCP request goes out. So it will fail, and the guy will be like, I can't internet on my computer, what's going on? So that's important even if you're not doing VLANs, to have that in there. Then when you say switch port mode access VLAN, give it a number and get out of the configuration. Then you're off and done. So config T after you become enabled, pick your interface, pick the, tell it switch port mode access for just about everything. Switch port VLAN access and the VLAN ID, so 13 or whatever, and then get out. Go through and do a show VLAN brief, and you'll get that kind of output. And then, presumably, you'll have some VLANs or some switch ports in the VLAN. Same deal applies for extended VLANs. On particular types of switch, you have to set BTP transparent because dynamic trunking protocol is pretty slick. I think the use case is like if you switch in and out devices a lot. So it handles the trunk negotiation if both of the switches that are trying to connect both talk it. And this little chart is something you will see a lot of, at least in like the test for this week and the Cisco quote. So like if my switch is set to dynamic auto and your switch is set to dynamic auto, we'll have access. If mine says desirable dynamic and yours says dynamic auto, it will be a trunk. And so if you've got a Cisco switch that is connected to something other than a Cisco switch or something else that supports DTP, you probably want it off. And if you want trunking to happen, if you want multiple VLANs to travel across one wire, something else, so on a device that does not support this dynamic trunking protocol, set it to trunk. Those are the 5 switch port modes that you can set, and that's sort of the rubric of what happens when you set them and they connect to what. That appears to be clear as mud. No, I have a switch at home all alone. So the question is, do we need to put a VLAN into trunk mode if you've got multiple VLANs on a switch? The only time you need to trunk it is if the one VLAN appears on another switch. Conceivably, we're passing VLAN across the non-routed part of that. This is layer 2 stuff right now. So they're right to share it. So if you've got a switch here, a switch here, and you want VLAN 13 set up on these ports and these ports, that's the magic that lets them pretend like we're on the same network, even though we're connected by this layer. So that can be tricky. You need to be able to troubleshoot it. And Cisco is all fired up about troubleshooting stuff. Get into the troubleshooting stuff. Like everything else in Cisco, if you want to get rid of a VLAN, you do no VLAN ID in global config. So if you want to delete, what do we got? VLAN 1. Don't think we're going to be able to delete the default one. If we want to delete VLAN 5, no VLAN, no VLAN 5, and it's gone. If you don't have that set up, no problem. Unless it's like how you get the router. VLAN? Oh, because it shuts it off. Well, it doesn't automatically put the VLAN someplace useful. If you took fast Ethernet 5 and you put it on VLAN 10 and took it out of VLAN 1, when you delete VLAN 10, it doesn't have any place to go anymore. Right. So now you need to assign it to VLAN 1 for it to be useful again. Yeah. You should try that. It will be bad. If it's on VLAN 10 and VLAN 10 goes away, you should verify that. You should try that. Could have been. You guys are getting like the Cisco 3 that includes parts. So you guys got to do stuff a little more advanced than what they're doing now. So they want you to remember to use the show commands when you get into trouble. Start pinging across the wire. When you're doing this inter VLAN routing, take a look on which switch port things are plugged into. Take a look at routing configurations if you're trying to route. Do you remember the router on a stick configuration? Those words still make sense when you would set up a router so that it was one pipe with multiple VLANs and things would go from, so you'd have switch here, you'd have VLAN 1 and VLAN 2, you'd have your router up here. And if something on VLAN 1 wanted to talk to something on VLAN 2, would go up, hit the router, and get routed back down. This is the old school way. And then when you upgraded it to the router on the stick, you'd have, here's your switch, and here is a bunch of VLANs on one wire going to the router. And then interface Ethernet 0 has sub-interface Ethernet 0.1, and that's VLAN 2. Yeah, same thing. I don't know if everybody's remembering Cisco too, as well as we might hope. But like that's the router on a stick thing. Now you're down to one wire, but it's got many VLANs on it, and the router is still routing for you. Maybe not the world's best configuration in the really real world, but oftentimes that dot that you're talking about, that sub interface, that's what they're saying. Show interface will tell you that stuff. Here's a list of things to check. And here's our router on 2-stick. IP addresses. If you accidentally put this PC into, 172.17.100 instead of 172.17.30, if you put it in the wrong subnet, that's not going to work. Make people sad. Same thing with all the sub interfaces. On these guys, if you're doing the router on a stick thing. So what they're trying to tell you here is that every IP address in VLAN 10 needs to appropriately line up with the addresses. Every one in VLAN 30 needs to line up with the addresses over here. And show running config and show IP interface are the commands. If you're going to use this whole VLAN trunking protocol, things you will usually show up with screw up: passwords, names, If everything is a client and nothing is a server, it doesn't work as well as you might like. If the revision number you put in there is wrong, if there's something wrong with the stuff we previously talked about, mismatches on those trunking modes, that little set of 4x4 boxes where they've got to line up to be set to the same to the appropriate mode to do what you want them to do. Native VLANs set differently, or not allowing all of the VLANs that you want to allow to go across the wire. That's their little checklist of things that can go wrong that you should start with after you've verified things like the cable works. And start at layer 1 and work your way up the stack. So here we are at layer 2. Now we're moving on to layer 3. So sometimes you have these fancy schmancy multi-layer switches. This is the difference in their raw rings. The layer 3 switch, it gets the little 8-grade star of chaos on it. It understands VLANs. Cool. Catalyst is the model. You mentioned we talk a lot about models. That's the name of the switches that do this. They kind of dropped that in a lot of their modern ones. But it will do what's called a routed port. It's got a port that will behave like a router. Kind of nice, that whole router on a stick deal that we were talking about. It will also create that SPI so that you can work with it in band. It will route inter-VLAN and it'll route SPIs. The idea is then it can go onto the core, the distribution layer, sometimes the access layer, without slowing down the rest of it. Kind of slick. You can do SPIs on any VLAN, so don't think that you just need one. And the first time that comes up, it creates an SPI for that particular VLAN. So here are switches that can behave a lot like routers. Spend the extra bucks to buy yourself one of these fancy schmancy catalyst switches. And what it lets you do is have a routed port. It's not necessarily part of a VLAN. They don't support the fancy sub interface deal that you can do on a genuine Cisco router. Generally, are like point to point, used to get like a switch back to the core usually. When a lot of companies, when we busted up our network into, segmented our networks and put firewalls between them, this was a really useful place for routed ports. So you'd have sort of an access layer switch with a routed port that brought you back to the firewall that got you the rest of the internet. So if this is sales is over here and marketing is over here and creative's over here and maintenance is over here, each of these could potentially be firewalled off from each other, and each of them could be on their own subnet. They could each have their own set of IP addresses and whatever. And if you've got a firewall in the middle here, it lets you make sure that like sales traffic going over to the marketing department, marketing traffic going to the production department. So what used to take 2 different pieces of hardware in 2 different boxes now can be done in a single frame with one routed port that's basically doing all, not everything that a router can do. They won't do NAT, they won't do a bunch of more advanced features that routers do, but they do enough to get that done, which was kind of one of the big use cases for these things, that they could route, they can do like DHCP helpers, so they can pass along DHCP stuff to, if the DHCP server's over here, this thing can talk to it, they can pass it on to the clients down the street. Upshots. So when you configure that no switch port interface, and then pop in some commands on the right mode, on the right device, you'll get a chance to play with those in the labs. Things that you can screw up, well, it's easy to mistype a VLAN. It's easy to put it in the wrong port. If you screw up the IP address or subnet mask on the SVI, you're going to have problems. It's basically not going to work. Routing, you have to turn it on. Each interface that you're doing there should have one. Generally, you're going to use static routing for these sorts of things. And then, of course, your hosts have to have the right IP address. They have to have the right gateway, just like all your other. I think they could have done better with the fonts. But like you've got a little more space to play with. Why that's bothered. But that's it in a nutshell. VTP totally could have made like a hell of a lot better. I wish I'd have known about this back in the day because you can do some tricky stuff with it where you have like redundant links and stuff. Server, client, and transparent are the three modes you have to remember. Remember the VLAN DAT thing. Um, if it gets a newer update with a higher revision number from the server, it will erase its VLAN DAT and take the newer update. That's why we keep revising. Then remember when you're troubleshooting these things, simple stuff like mistyped IP addresses, mistyped VLAN IDs, mistyped whatever, which can all get you into trouble. And that's